Bismillahirrahmanirrahim. New syllabus reads SSC 1, Unit number 5, Gravitation. Exercise 5, Numerical Problem 5.1 to 5.4. In first numerical, find the gravitational force of attraction between the two spheres each of mass 1000 kg. The distance between the two centers of sphere is 0.5 meter. Here we can see that two spheres, each of mass is 1000 kg. Now we write the given data. Mass of first sphere m1 is equal to 1000 kg and mass of second sphere m2 1000 kg. Now, the distance between sphere D is equal to 0.5 meter. Gravitational constant capital G is equal to 6.673 multiplied by 10 raised to power minus 11 Newton meter square per kg square. To find gravitational force is denoted by Fg is equal to question mark. Now the formula by the Newton's law of gravitation, F is equal to G m1 m2 upon d square. Solution by the Newton's law of gravitation, F is equal to G m1 m2 upon d square, putting the value. So 6.673 multiplied by 10 raised to power minus 11 multiplied by 1000 multiplied by 1000 divided by d 0.5 whole square. Now we calculate the value 6.673 multiplied by 10 raised to power minus 11 multiplied by 1000 multiplied by 1000 upon 0.25. 6.673 divided by 0.25 is equal to 26.7. Multiply by 10 raised to power minus 11 and 1000 is equal to 10 raised to power 3. So adding the power minus 11 plus 3 plus 3 is equal to 26.7 multiplied by 10 raised to power minus 5. We can write in scientific notation. So the force between the two spheres F is equal to 2.67 multiplied by 10 raised to power minus 4 Newton. Final, the result, the gravitational force between the two spheres is 2.67 multiplied by 10 raised to power minus 4 Newton. Now we can solve the second numerical. In second numerical, the force of gravitation between the two identical spheres kept at 1 meter apart is 0.006673 Newton. Find the masses. First of all, we can read statement carefully. Two identical masses. It means both masses are same and distance between their spheres is d is equal to 1 meter apart. And given that the force F is equal to 0.006673 Newton. Now we can write the given data. Here the gravitational force F is equal to 0.006673 Newton and distance between the sphere d is equal to 1 meter. The gravitational force constant is denoted by capital G. Its value is always constant. 6.673 multiplied by 10 raised to power minus 11 Newton meter square per kg square. To find the mass of sphere is equal to m1 is equal to m2 is equal to m, because both spheres are identical. Now we can write the formula by the law of gravitation. According to the law of gravitation, F is equal to G m1 m2 upon d square. Here m1 is equal to m2, so we can write in solution by the law of gravitation. F is equal to G m1 m2 upon d square. Now putting the value m1 is equal to m2 is equal to m, then the equation will be changed. M square is equal to f d square upon g, taking square root on both sides. Then equation will be changed in this form. M is equal to f d square upon g whole square root. Now putting the values, then f m is equal to value of f 0.006673 multiplied by 1 square value of d. So 1 square upon putting the value of g 6.673 multiplied by 10 raised to power minus 11. Now the value becomes 6.673 multiplied by 10 raised to power minus 11 minus 3 upon 6.673 multiplied by 10 to the power minus 11. The answer m is equal to 1 multiplied by 10 to the power minus 3 plus 11. When power move upward, the negative sign will be changed. So 10 to the power minus 3 plus 11, it will be become 1 multiplied by 10 to the power 8 whole square root. Taking square values, then 1 multiplied by 10 to the power 4 kg. The final answer m is equal to 10,000 kg. Thus, the mass of sphere m1, m2 is equal to m is equal to 10,000 kg. Result, the mass of sphere m1 and m2 each have 10,000 kg. Now, in question number 3, find the acceleration due to gravity. Acceleration due to gravity means the value of small g. On the surface of Mars, the mass of Mars is 6.42 multiplied by 10 raised to power 23 kg, and its radius is 3,370 kilometers. Now, the given data mass of Mars is equal to 6.42 multiplied by 10 raised to power 23 kg and radius 3,370 kilometers. Now, we write the given data mass of Mars m m. M, capital M denoted by mass and small m denoted by mass. So its value is equal to 6.42 multiplied by 10 raised to power 23 kg. Now the radius of Mars Rm is equal to 3,370 kilometers. Now change in scientific notation, move the decimal place from this point to this point. Here arrow at shows, then this point to this point 1, 2 and 3, it can be written as 3.37 multiplied by 10 raised to power 3, and 1 kilo is also equal to 10 raised to power 3. Now the final answer 3.37 multiplied by 10 raised to power 6 meter. Gravitational constant capital G is equal to 6.673 multiplied by 10 raised to power minus 11 Newton meter square per kg square. To find the gravitational force is denoted by G, so we can write that Gm gravitational force on Mars is equal to question mark. Now write the formula on the surface of Mars, the value of G. G is equal to capital G, gravitational constant, mass of Mars divided by radius square. Now putting the values, then to find the solution on the surface of Mars, Gm is equal to Gmm upon Rm square. Now putting the values, then Gm is equal to 6.673 multiplied by 10 to the power minus 11, the value of G multiplied by mass of Mars 6.42 multiplied by 10 to the power 23 divided by radius of Mars 3.37 multiplied by 10 to the power 6 whole square. We calculate the value multiplying 6.673 multiplied by 6.42 is equal to 42.84 multiplied by 10 raised to the power 11 plus 10 raised to the power 23. Now taking the square of 3.37 is equal to 11.357 multiplied by 10 raised to the power square is equal to 10 raised to the power 12. Now the final answer becomes 3.77 multiplied by 10 raised to the power minus 11 plus 23 minus 12 is equal to 3.77 multiplied by 10 raised to the power plus 23 and minus 23 become 0, and 10 raised to the power 0 is equal to 1. So the final answer 3.77 multiplied by 10 raised to the power or 0 is equal to 3.77. The value of Gm is equal to 3.77 meter per second square. The final result, the acceleration due to gravity on the surface of Mars is equal to 3.77 meters per second square. Now, the last numerical of today's lesson is the force, the acceleration due to gravity on the surface of moon is 1.6662 meter per second square. The radius of moon is 1740 kilometer. Find the mass of moon. Now we calculate the mass of moon when the acceleration due to gravity. The value of G is given 1.62 and the mass will be calculated by this to write the given data. Here, the gravitational acceleration Gm, G is denoted by small value. So, due to the gravitational acceleration denoted by small g, small gm is equal to 1.62 meter per second square. Now the radius of moon Rm is equal to 1740 kilometers. Decimal place from the arrowhead, this point to this point. Here three values 1, 2 and 3. It can be written in this form 1.74 multiplied by 10 raised to power 3 multiplied by 10 raised to power 3 of the value of kilo. So the final answer 1.74 multiplied by 10 raised to power 6 meter. Gravitational constant, the value of capital G 6.673 multiplied by 10 raised to power minus 11 Newton meter square per kg square. To find the mass of moon mm, then formula become mass of moon is equal to gravitational acceleration gm on the moon and radius of moon square divided by value of gravitational constant. Now we calculate the solution, then mass of moon is equal to putting values of g 1.62 multiplied by 1.744 multiplied by 10 raised to power 6 whole square because the radius of sphere divided by value of g 6.673 multiplied by 10 raised to power minus 11. Now taking the square of 1.74 is equal to 3.027 multiplied by 10 raised to power 6 square will be equal to 10 raised to power 12. Now we further calculation mass of moon is equal to 1.62 multiplied by 3.027 divided by 6.673, the final answer 0.735 multiplied by 10 raised to power 12. This minus value become positive, so plus 11 is equal to 7.35 multiplied by 10 raised to power 12 plus 11 and decimal place move from this place to this place, so the minus 1. The final answer 7.35 multiplied by 10 raised to power 22 kg. The final mass of moon is 7.35 multiplied by 10 raised to power 22 kg. Thank you. For remaining questions, see and other videos. Best of luck.